the center or the origin, or I could have the center shifted around the coordinate plane. Okay, so our first one is going to be at the origin. And it's going to be a nice little, I'm going to go ahead and put it here, x squared plus y squared equals r squared. All right, so just like we saw last week when we did this, it's got an x squared, it's got a y squared, and then this number is going to be whatever the radius is squared. So if that number was a 9, then the radius would be 3. Okay, so our center, I said, was at the origin, but that would be the ordered pair 0, 0. And then our radius is r, since that's r squared. All right, now if it's shifted around the coordinate plane somewhere, so I'm just going to say shifted, it's going to have that h and k in it that we saw last week. So we're going to have an x minus an h quantity squared, and then plus y minus k quantity squared, and then still equal to r squared. All right, so that h and k is going to be the exact same thing that we dealt with our parabola, our v shape, our absolute value. All right, we looked at the cubic ones, I think. All right, now, does the formula have minus signs in it? Yes. Anytime there's minus signs in the formula, one way to look at it is, okay, when I pull the number out, I'm going to take the opposite of whatever it is. The hk is going to be the origin. This h, when we shifted our other graphs, shifted left to right, right? So that's going to give me left to right along the x-axis. That will be my x-coordinate. The k in our other formulas told us how to shift up or down. Okay, so again, they're both going to be opposite, okay? But this tells me how I'm going to move up or down on the graph because it's going to be along the y-axis. So my center, I'm going to pull out the positive values of those, so opposite, so hk, and then the radius doesn't change because we still have that r squared sitting on the end, so it's still an r. All right, even if you did do some of that now, if it's starting to come back and you did some of that your sophomore year, you may not have done general form, okay? General form, and I've seen it written in a variety of different ways, but I think your book just writes it as an x squared plus a y squared plus a dx plus an ey plus an f equals 0. Okay, so we'll have definitely an x squared term, y squared term, we'll have a plain x term, we'll have a plain y term, and we'll have a constant. All of it's on the left-hand side. It needs to be placed in that order. So if you have to write an equation for a circle in general form, you're going to make sure that you follow this order. All right, and then it'll be set equal to 0. Have we seen that one before? No. Okay. All right, not hard though. Now, initially, we're going to do really super simple questions. I'm just going to ask you to look at these forms, pull out the center, pull out the radius. Okay, low-level questions. All right, I ought to also be able to give you the center and the radius, and then you put them in one of these two forms, because the standard form is designed in that way so that you can just real quickly look at it and tell what the center is, what the radius is, or write those equations. All right, so we'll do a variety of examples here with those easy concepts. All right, let's say you're given a center, I'm just going to use C for center, that is 3, negative 4, and then you're given a radius, so I'm going to use lowercase r equals 5. All right. Write the standard form. Okay, so they give you information you need, and you got to write standard form. Okay, I have a center that is away from the origin, so I'm going to take those. I'm going to use the shifted version. I'm going to put the x coordinate with the x. I'm going to put the y coordinate with the y squared term, x squared term, and I'm going to do the opposite of those numbers when I write it. Okay, so can you look at the form and then we just write it? So it's going to be parentheses x, then what am I going to write? Opposite of, I need my x coordinate. 3, and it'll be minus 3. So think opposite of the x coordinate goes in with the x, quantity squared. Okay, because what I'm doing is I'm following this form right here. Okay, then I'm going to have a plus. Now I'm going to pull out the y coordinate, so I'm going to have a y. Opposite of the y coordinate is plus 4. And then I got to quantity square that whole entire thing. All right, looking at our formula, it's an r squared. If r is 5, then this number has to be 25. So very low level skill wise, all you got to do is pull the numbers, put them in the equations where they go. It's almost like pulling out slope and y-intercept out of the y equals mx plus b equation, or putting them in to those equations. Okay, so we good there? Have you ever done that before? Have you ever done what we just knew? Okay, so you were not kidding me when you said you have not done circles. Okay, now if I can give you the center and the radius, and then you put the things into the formula, I ought to be able to go the other way around. I ought to be able to give you an equation and then ask you to pull out the center, pull out the radius. Okay, so this time maybe you are given, say, maybe an x plus a 5 to the second power plus a y squared and then equals a 4. And instead of saying write the standard form, because I've already got that, I'm going to say find the center and radius. Okay, so you're going to find the center and the radius. Okay, now as we shifted our various graphs last week, you don't have to shift at all. You can shift both left and right and up and down, but then can you also just shift left or right? Can you just shift up or down? Yes. Okay, so looking here and knowing what you know about shifting our other functions, is this shifted both directions? It's not shifted both directions. There is no number on the inside of what's being squared here, so it is not shifted up or down. It is only shifted left or right. Okay, so the center then is going to be, pull out that number as a negative, as an opposite. So the center, well, I'll put this in red. The center will be -5. Now, what number do I put for the y coordinate? 0, because it's not shifted. Okay. The radius, if I have a 4 here, then the radius has to be 2. You take the square root of that. All right. Could I have a 7 there? I could have a 7 there. If you had some number that you couldn't take square root of, you would just literally write square root of 7. All right, no reason to grab a calculator or go to a decimal. Radius would be square root of 7. Okay, so again, very low level questions here. Okay, now let's beef it up and make it a little bit more challenging. We think we're good on that? Is one example of each of those pretty good? Because we're low level questions here. Okay, all right, now a little bit more. All right, remind me again, did you tell me you have completed the square before, or you did not complete the square in Algebra 2? We did? Why it's saying we did. The rest of you are looking like, yeah, I don't remember that. All right. Yeah, well, and you may not remember the process, but if you've heard the phrase completing the square, that would be a plus if you've heard that phrase. Okay, that means you would have at least done it. Now we just have to refresh your memory. Okay. Now, in your notes, I have put this, completing the square. I put that on the top of this example. In the directions, it's not going to say anything about completing the square. This is you have to know that's the process you have to use to be able to get to the answer. So the question you're going to see is going to be something like, rewrite the equation in, and then I'm just going to do SF because I'm running out of room here. Okay, rewrite the equation in standard form. That's going to be your set of directions. Okay, so nowhere in that set of directions does it say use completing the square to come up with the answer. That's the part you have to be able to do. What they're going to give you then is they're going to give you something like x squared plus y squared plus 10x minus 4y minus 20 equals 0. So they are giving you general form. All right, general form. Now, from here to the end, this is the process to complete the square, okay? I have to complete the square to be able to get to standard form. First thing I'm going to do, I'm going to rearrange the terms. I want x squared and x next to each other. I want y squared and y next to each other. And this constant, I want moved over to the right-hand side of the equation. So all I'm going to do, and I'll put this in purple, this first line, all I'm going to do is rewrite, rearrange, rewrite, however you want to say it, rearrange the terms. So I'm going to have, I want to be able to color code this. So let's make this a blue. X squared plus 10x, all right, and then plus y squared minus 4y. I want to add 20 to both sides because I want to move that over to the other side. So there's a plus 20. All right, now I can start thinking of this as I'm grouping these together and I'm grouping these together. All right, and then eventually you're going to understand hopefully why it's called completing the square. Okay, now my next step, I'm actually going to complete the square. All right, when you in Algebra 2 were factoring trinomials, hopefully you were taught the formula for factoring a perfect square trinomial. Okay, right here, that's not a trinomial, right? But if I had x squared plus 10x, and then I had something else right there, I can force this to become a perfect square trinomial. All right, so I literally will draw this line with a blank line there, so I'll remember, hey, I got to put something there. All right, y squared minus 4y. If I added something right there, I could force this to turn into a perfect square trinomial. The 20 is still there. All right, now what do we know? I'm almost running out of space here. What do we know about equations? If I put two things here, if I add two quantities right here, that's on the left-hand side of the equation. Don't I have to keep my equation balanced and do the exact same thing on the other side? So I need two blanks right here. I'm doing two things over here. I got to make sure I put two things over there because I got to keep my equation balanced. All right, now, shortcut way to come up with what goes here. All right, it's a perfect square trinomial. So then, in other words, when I factor this, I want it to factor into x plus some number, quantity squared, because that's how we factored a perfect square trinomial. So, shortcut, take this number, take half of it. So half of 10 is 5. Square 5. 5 squared is 25. So plus 25 is going to make that a perfect square trinomial. If I add 25 on the left, I have to add 25 on the right. Okay, there's just no way to get around that. Got to keep that balanced. All right, now we are going to, it really doesn't matter, that negative, because when I square something, it becomes positive. Okay, but so you can think of it as -4, half of -4, or just think of it as the 4. That works. Half of 4 is 2. 2 squared is 4. Okay, so plus 4. If I add 4 on the left-hand side, I got to add 4 on the right-hand side. Totally running out of room on my paper. Okay, sorry for writing so small. Okay, now that right there is completing the square. I completed the square because I created two perfect squares. Okay, so completing the square. I did it right there. That's what it means. That's why this process is called completing the square. Okay, now I don't care how you do the next step or how you think about the next step. All right, this is a trinomial. Can you factor the trinomial? Yeah, and it should look like x plus some number, quantity squared. That number is going to be the square root of that 25, which is going to be a 5. So when I factor this, I get x plus 5 quantity squared. But doesn't that look like part of my standard form for a circle? All right, I want it to look like that. Okay, same thing here. You ought to be able to factor this trinomial. It should look like a y All right, and then it's not going to be a plus on this one. It'll be a minus because there's a minus sign right there. So you can always think of it's going to be whatever that first one is. All right, so I'll have a y. That first one right there is going to be a minus. If I factor this, it's going to have to be the square root of 4, which would be a 2, and then quantity squared. So I factored it. All right, and then over here, you just got to add all that up. What was that, like 49? Okay, so now, did I just convert that equation into standard form? Okay, always half there, always half there. It's a square root of this one. If you remembered how to factor that perfect square trinomial, it works really good. Now, could there be a part B and a part C to this question? Could I say rewrite in standard form, part A, part B, find the center, part C, find the radius? Could I not tell you to rewrite the equation? What if the directions just gave you this and then it said find the center and find the radius? Then you're going to have to know you've got to complete the square to rewrite it in standard form to be able to get there. Okay, so stepping you through, here's a part A, here's a part B, here's a part C, is more spoon feeding you, and then just writing a set of directions as, hey, here it is. You figure out how to get the circle center. You figure out how to get the radius. Okay, big difference there.